Welcome to SolarWorks for Illinois. I'm Tim Montague, your host. This is the monthly free webinar from Continental Electric, where we dive into solar energy. Today, I'm really pleased to have Sean Moran with Skender Construction on the show. Sean is a lead AP and a FIA certified builder. So for all of you who know about green building, you know that Sean, with those credentials, is very dedicated to green building. He joined Skender in 2016. After a career as a general contractor for himself. He had a company called New Grange Construction. And then Sean was attracted to the work that Skender's doing. Hopefully we'll hear a little bit about Skender today. But the thrust of today's presentation is going to be on net zero construction and how we get to net zero with solar energy. Today is September 25th, and this is SolarWorks for Illinois. I'm Tim Montague. You can reach me at tmontague@cecco.com. Welcome to the show, Sean. I'm so happy to have you here.
Thank you, Tim. Thank you for having me. Pleasure to be here. Do you want me to kick it off, Tim?
Yes, please. Just dive right in to your presentation, and then I'll make a few announcements at the end, but you have the floor.
Sounds good. Well, thanks again for joining. I'm guessing that those that are here have an interest in energy efficient buildings, net zero energy, and solar. So hopefully I can enlighten some people on the topic, and hopefully we can take some questions at the end as well. So as Tim mentioned, my name is Sean Moran. I'm a senior project manager with Skender Construction in Chicago. We are now a design, build, and manufacturing company. So our primary focus is general contracting, but we have ventured into other avenues. And for really the sole reason of making construction more economical and more efficient. So my contact information is on the screen, and certainly feel free to reach out to me. Direct with any questions, comments, or potential projects or anything you want to talk about. Happy to keep this conversation going. So we'll get right into it. Tim did ask me to provide the audience, to let them know I am a credible source. So although I don't like talking about myself often, I am a Passive House Builder certified and a lead AP. So I've been pursuing sustainability for over the last 10 years. And I say pursuit intentionally because I think it's always a pursuit. We're not quite there yet. And some may say there's a long way to go. I know there's been a lot of improvements over the last 10 years. So I'm excited to be, I suppose in this industry at this time, because there's a lot of opportunity here. So moving into the webinar. So there are some learning objectives today. We're going to try and keep it high level with a little bit of technical details when we get into the construction, but what is net zero? Why are net zero energy buildings important? And what is the path to net zero? So moving in, what is a net zero energy building? So by definition, my definition, it's on an annual basis, is a building producing enough energy from on-site renewables to offset the amount of energy it uses from the energy grid. So as most of us know, our buildings will typically be tied into the utility grid. To break down the definition of net zero in a nutshell, it's, are we producing enough energy on site to offset the energy that we need from the grid? And to talk about that a little bit, essentially, with solar, we're not going to be producing energy at night, but we may be demanding energy at night. So that's where we're tied to the grid. Battery storage is certainly an option for storing solar, and we are seeing prices come down quite a bit. But I think that's one of those industries and avenues that's still got a decent way to go, but I'd say in the next couple of years we'll see a lot more affordable battery storage. Another definition I have here, this is according to the Department of Energy. They are stating that a net zero energy building it's an energy efficient building on a source energy basis, which is the actual energy delivered to the site. Is it less than or equal to the on-site renewable exported energy? So what that really means is the Department of Energy has factored in that there are transmission losses when we are tied to the grid. So the energy that's being produced, for example, from a coal-fired plant has to travel across utility lines, and there are energy losses there. So the Department of Energy determines a net zero energy building. It's a little more stringent. You have to produce more energy than you're actually using on site because it's factoring in the transmission losses. And here's a little example of what I mean by the source energy. It's just showing your coal-fired plant, your transmissions lines, then it gets to your home or your office building, and there are losses along that way. How do you make it net zero? You offset it by the amount of photovoltaic, PV, solar. Alternatively, you can look at it from site energy. Are we just using the same, equal to the amount of energy we're using just at the site as production? So what that really means is when we look at our energy bill, it may say for a home, for instance, we're using 12,000 kilowatt hours per year, or an office building, we're using 100,000 kilowatt hours per year. Are we producing that same amount of energy on site? So that would be considered net zero site energy. The net zero source energy, as I previously mentioned, is factoring in the transmission losses as well. So why are net zero energy buildings important? Well, there's three major industries in the US and the world, and buildings are the most energy intensive. So buildings constitute about 45% of the energy that we use as an economy, as a planet, and therefore there is a direct correlation to the amount of CO2 emitted. So net zero energy buildings are important because they have the greatest impact on energy and CO2. So if we look at the graph on the left, so right now we're using about 10% renewable energy in America, and there are trends that renewable energy is going up every year, but we're also using more and more energy every year. So the graph on the right just shows the energy that we're using. So it's continually go up as population goes up, and quite frankly, we're not becoming more efficient in our behaviors. We tend to do things that are easier and simpler, that may be more convenient and use more energy. But when we're talking about net zero energy buildings, we're not talking about behavioral changes. We're talking about what needs to be done in design and construction to get to that point. So again, right now we're using 10% renewable energy. There are some goals, both federally and state, 25% by 2025. But the big picture is how do we get to 100% renewable energy? I want to make a correlation here between energy, carbon, and its effect on the environment. So we can paint this picture as to why net zero is important. So on the left-hand side, we can see that global carbon emissions have been steadily increasing for the last 100 years. And it's gone a lot more dramatic over the last 50, even 30 years, you could say it's had the steepest incline. If we look on the graph on the right, we can see that there's a direct correlation to global temperature. So it's a pretty consistent trend between global temperature and carbon dioxide and energy use. So this is taken from NASA, actually. This is the data that they have to support the evidence behind the correlation. And as you can see, that it's been a pretty stable planet for a long time, up until about the last 100 years. It looks like a very perpendicular linear lineup, because that breaks down the last 50,000 years within an inch on the screen. But the previous graphs show it's a little more linear. So we've seen, 7 of the warmest years on record have been in the last 10 years. There's a lot of data that's supporting this, obviously. So, I don't think it's a debate anymore. but it keeps reminding me as to why buildings are so important, and what we're doing in this industry has a significant impact. Other effects of increased global temperature and carbon dioxide in the environment are just weather disasters. So weather disasters continue to go up both in the US and globally. So it's the same trend: more CO2 in the environment, more natural weather disasters that cost the US and the world billions of dollars a year. So that's why we need to use more renewable energy. That's why we need to do net zero energy buildings. So paving the way to net zero energy. This is a very broad picture here, but these are things that we can do as individuals in our daily lives. And then when we get to work on a project, these are some steps to outline. So number one, first and foremost, we need to advocate for and support programs and policy that help create this sustainable future, meaning renewable energy incentives, energy efficiency incentives, policies that help promote this. Over the last 10 years, I've saw the building code dramatically get better. I fear that if the building code hasn't got more stringent or didn't get better, we'd be much further behind in this path towards net zero energy. So I can say, firsthand, as building codes get more stringent, all of the competition has to achieve these same goals. And it really creates an environment to build more energy efficiency buildings, where we're being mandated to do that now. So we're not mandated to do net zero energy yet, and we are currently on the 2015 International Energy Conservation Code in the state of Illinois and in most states. California is certainly pushing the envelope towards net zero as a building policy. But that's one thing we can do on individual lives, is just support these types of programs and policies. If you are fortunate enough to be in a position to be on a building project, and perhaps you are the decision maker, perhaps you are just part of the team, the first step would be to set the goal of net zero energy. Even if it's not feasible at the onset or the completion of the project to put solar on your roof, you can still set the goal of net zero energy as a long-term goal. And we'll get more into details about this, but that certainly means driving the energy consumption of the building down at the beginning of the project so that you can offset it with solar later. Another step would be just to hire a great team. It's crucial to the success of a high-performance building or a net zero energy building that you have an experienced group of designers, architects, contractors. There is a lot of integration here between these different parties and a lot of collaboration. And it's a very iterative process. As we'll get into a bit later, it's just a continual iteration of designing, budgeting, testing on building performance simulations and energy models, and then changing the design, tweaking the design to achieve the goals. Which is the last point I suppose I just made was the building performance modeling. When we get into construction, we need to be able to have quality control checks along the way, and then we need to measure performance once these systems are installed. So we'll get into a bit more of the technical stuff and how do you achieve a net zero energy building. And the big point you want to drive home is you need to reduce energy consumption first. So again, to get to net zero, we need renewables. But let's just focus on how do you reduce energy in the first place. And there's really four main criteria that need to be focused on. One is the building envelope, two is the mechanical systems, three are passive elements on the site, and then four being the renewable energy. So we'll get a little bit more into these details now. So as I previously mentioned, the integrative design process. So this is essential to any net zero energy project, and I would say any truly high performance building. So hopefully by this stage, we've got a driver and we've got a team, an owner, and we've got a team that are focused on the goal, one of the goals, and that goal being net zero energy. So we actually start on this graph in the bottom corner. Build a knowledge base. So certainly there has to be some knowledge. Certainly on the team, there has to be a pretty extensive knowledge base. But from an owner standpoint, you don't need to know a lot about net zero and how do you get there. Other than, I would say, be passionate about the goals. So I'm going to just go around the circle. I'm not going to spend too much time on each one, but in order to get to the net zero, we need to establish some parameters. Where is this building being built? How big is the building? How big is the roof so that we can put solar on it? How big is the site? Potentially we need to do a ground mount solar system. So what are the parameters of the building and the site? Those are big factors that we need to, consider every step of the way to get to net zero. Compile OPR, so the owner's project requirements and basis of design. What else is important to the owner so that we're not missing anything, we're not skipping over anything that is important to the owner outside of net zero energy. The concept design. So a shoebox model. What's meant by that is simply just a three-dimensional model, no details necessarily, but it begins to get a good sense of how much volume is in this building, where windows located. That would be a next step, is perhaps a little bit more detailed than the shoebox design. But this information, again, is iterative, and it informs a lot on how much energy the building's using. So as we go into schematic design, we're going to do some more computational models. So that would be daylight and solar access. This would be the design team and the consultants doing this work. The computational fluid dynamics, another fancy word which is used a lot, is hydrothermal analysis. And it's just to determine how moisture and vapor is handled in these types of buildings, which is obviously very important to the durability and the health of the building. And we'll get back to that in a little bit later. At this stage, at schematic design, we can begin to understand how much energy is this building going to use based on the occupants, how many occupants, the size, again, glazing, insulation. In schematic design, we should have some of this information that we can start to model and determine how much energy is this building going to use. And a short segue here, for those that are viewing in Illinois, ComEd have a program and a team of engineers at a third party called Seventh Wave Engineering. They do free energy modeling. So any project is eligible for this, to get free energy modeling. So I'd highly recommend making this part of every project. And that's what we're doing at our company, as well as where we're utilizing those free services on every project. Next step would be design development. It's just more iterations, more information informing the design, how much energy we're using. And then as we go into construction documentation, we begin to get to a sense, are we achieving net zero? Is a modeled building using a reduced amount of energy to a point that we have enough roof space to offset that with solar, or enough site space to do a ground mount system? This graph shows bidding and construction after construction documents. This is certainly, a way to do it. I would suggest that there's bidding and construction during the whole process. It's going to minimize any redesign work, and it certainly gets you to construction sooner. If budget wasn't the biggest driver, and if time wasn't the biggest driver, this is certainly a route to do it. But I would suggest bidding and budgeting throughout the whole process. Next step would be commissioning. Has the building been built the way it was supposed to? And monitoring post-occupancy. So that's kind of a general sense, and we're going to highlight some of these areas now. So the first critical portion is the building envelope. So when we talk about the walls and the roof and the slab, glazing, doors, any openings in the building envelope, these are critical points. If we don't get this right, it doesn't matter what we do on the mechanical system or the electric loads, water heating, it doesn't matter. We're going to have energy in the form of heating and cooling that we're paying for to heat and cool our space. We're going to let that just leak out into the outside world. And that is the critical number one step that really everyone needs to understand. And it's quite frankly, it's not the prettiest thing. It's not the most exciting portion of a building, but it's certainly the most critical. So whether it's residential or commercial, there's things that need to be focused on, and it's all about air infiltration and getting the right things on the envelope. So certainly we want good insulation. We want to do continuous exterior insulation when we can. But the air sealing is to me, it's probably the most critical. And there's certain ways to do this. One is, we can collaborate with, as the general contractor or our subcontractors can collaborate with the design team to get these details into drawings. If that opportunity doesn't exist, really want to push your design team to get these notes onto the drawing. And it's as simple as continuous beads of adhesive, continuous beads of sealant. You can see these highlighted on the left. It's very critical that every join in a floor or a window is 100% sealed. The air tightness levels are now mandated in both in the state, local, and federal building codes, and that is because everyone understands that if your building is leaky, you're not going to have an energy efficient building. On the right-hand side here, you see a red line around the building envelope, and that is a practice that a lot of designers, contractors do. As simple as it sounds, it's going around the building with a red pen to determine where's the differences, where is the difference in materials, where the different materials join, where are abutments in the building. These are critical points that you want to focus on, and you want your whole team, the design and your construction team, to understand each one of these details. What are we doing there? Are we going to use a sealant? Are we going to use a tape? Are we using foam? How do these materials work together? This is critical. I also want to point out too, so the blower door testing is part of the building code now. So you have to pressurize these buildings in construction to determine how leaky it is. This information goes into the energy model. So when the energy model is done previously, they make some assumptions on that energy model, and then you test that in the field, and that's really how you can determine how much energy you're actually going to be using. So one nice tip and trick is to do that blower door test in the rough stage. So before you put on your drywall, you've got your windows and doors in place, you're insulated, and perhaps you're not insulated actually, but you've at least caulked and sealed all of your penetrations. You can do the blower door test, and you can determine at that point how leaky the building is. So your air barrier is in place at that stage, and you can determine and rectify any issues that you might run into at that stage. So another thing to point out is thermal bridging. So thermal bridging is also very critical. As we look, we can just jump right to the picture on the right there. So that is a thermal imagery that's showing a building in Chicago that has a thermal bridge. So what that really means is that a building material is going from the inside to the outside of a building. And in this instance, it's just showing that we're actually heating the outside environment. So all that heat that it took to heat that building slab, in this instance, the concrete building slab or floor slab, is just radiating out into the outside world. So a lot of wasted energy there, an unbelievable amount of wasted energy there. But this, in any instance, it's a material that goes from inside to outside. It can be a cantilevered porch deck. It can be, even screws, long screws that go from inside to outside. These are all thermal bridges. It's trying to minimize or eliminate thermal bridges. So there's nice new innovations in this world. Something that you want to be mindful of when you're in design and construction, for that matter, is what are we doing to eliminate thermal bridges? The little diagram to the left here is showing there is a thermal break. So that's the future here is you put a thermal break. You can still build slabs from inside to outside, but it has a break here. So there's no continuity of the rebar in this instance or the slab. It's broken by either fiberglass, some rigid foam, but it's still structurally sound. So obviously all this stuff is designed and tested, but minimizing thermal bridges is critical. Moving on to mechanical systems. So very important in driving the reduction of energy consumption in your buildings, and a move away from what used to be done was rule of thumb mechanical systems. We need to properly size mechanical systems. There was a stage going back even 5 years ago where people would say, oh, 1,000 square foot, I need a ton and a half of cooling in my building. That's very generic, and quite frankly, it's lazy design, and it's not going to get us to energy efficiency, and certainly not net zero energy. So we need to properly size mechanical systems. There's a lot of different calculations that the engineer and the design team need to be doing, but here's some examples: the manual J, the manual S, manual D, and T. These are all different types of calculations that need to be done to size the equipment, size the ductwork, and get it dialed in so that it's as efficient as possible right from the onset. And you're not wasting money either. So that's the other thing. We're designing it to the climate data wherever your building may be. It's sized appropriately for the climate, and it's sized appropriately for the occupancy load, the amount of glazing, the size of the rooms, the size of the building, all that good stuff. Properly sized mechanical systems, it's overlooked a lot, and I have to keep reminding our teams, have they reconsidered new information in the energy model so that they can change the system appropriately? As insulation levels go up, mechanical systems go down. As the amount of glazing, triple pane, if we did triple pane instead of double pane, the size of equipment can go down. So all of these things have a direct correlation, and this is when we talk about looking at the building as a whole building approach or as a holistic approach. So number 2 on the mechanical side is continuous and balanced ventilation and energy recovery. So we're driven, as I mentioned previously, to build the buildings tight. There is a nice saying build it tight, vent it right. Something we always need to keep in mind. But that's why, these homes are becoming healthier. There's a better indoor environment in these tight buildings that are vented correctly. There's a continuous ventilation of bringing in outside fresh air, but it's not bringing in freezing cold temperature. With these heat recoveries and the energy recovery, it's allowing outside air to cross a plate inside this piece of equipment that preheats this incoming air for free. So you're not spending energy or money to preheat incoming air. It's bringing the temperature right up, and it's a really great way to save money, preheat incoming air, and do energy efficiency. So some form of energy recovery or heat recovery, they're synonymous based on your environment, your climate zone. But it is important to have on every project. Number 3 point I want to make is the quality of the installation. The installation, that is. So that would be making sure that all ductwork is sealed appropriately, whether it's with a mastic, glue, or tape. The mastic is the recommended route, but it's making sure that all those joints are nicely done correctly, done tight, or it could be mechanically fastened. But either way, the installation is critical to making sure that the distribution is correct, the occupants are getting the right level of comfort, and that it is energy efficient. And then commissioning is just after post-occupancy, making sure that the testing is done, and that usually a third-party agent is the one doing this to stay neutral and make sure that what was designed is done correctly. The 4th is smart controls. So any form of building automation controls or heating and cooling controls, whether it's in your home or your building, smart controls are pivotal to keeping energy down. We don't need to be running mechanical systems at the same set points throughout the day. So based on occupancy, these items can be changed, and they certainly can be changed based on occupancy too. So without even setting timelines, it can be based off occupancy. We're doing a school right now, actually, and it's got carbon sensors in the building, so it can identify how many occupants are in the building and how much heat is needed, or fresh air for that matter. So moving on from HVAC, water heating. This is a next big item. In residential homes, it is more energy intensive than it would be in commercials. There are different options for water heating. So there's, like every building really and every component, there's not one size fits all. And that's what makes this industry challenging. It depends on so many factors and site conditions. But with the water heating, the heat pumps are a great option. Your tankless, instantaneous water heaters are excellent as well for their own benefits. With your gas or your propane storage tank being your least effective, I've been staying away from that. I don't really see too many of your regular storage tank type heaters anymore on these high efficiency projects. So I'd like to focus on the heat pump and the tankless. And, in simplistic terms, really, when we've got a storage tank, we could be heating up 50 or 100 gallons or more of hot water continuously throughout the day. It's like you're reboiling your kettle, every hour. It seems very wasteful, and it is. So I don't have a lot to say on water heating other than when you're in design, your distribution, if you can, ideally, if it's centralized distribution, there's not long runs, we want to limit that. But, ask the design team, ask the subcontractors, the contractors, about heat pumps or tankless for your project. So electric loads. So when we're talking about high performance building, net zero energy buildings, lighting is a low hanging fruit, so to speak, but it has a big impact on energy savings, and LED is one of those areas where it's been awesome to see the improvements over the last 5 years. Every single project is doing LED right now. And the light is great. The light levels are great. The controls and dimming is awesome. But some of the other items that are pushing the envelope as far as lighting goes are the smart controls. So the daylight sensor and the occupancy sensor. So there's a diagram on the right hand side there that just shows how these daylight sensors can work. You can dim fixtures in different locations inside of a building. Just based on how much light is getting into the building. So you can see the light that's closest to the window would be getting the most natural light. So therefore that fixture itself is only needs to use 20%, for example. The deeper you get into the building, it may need to ramp up a little bit. But as opposed to running all of these on 100% or all of these on 50%, these daylight sensors really allow you to dial in energy efficiency. So the next important thing on electrical loads would be appliances. We need to be pretty strict on specifying Energy Star rated appliances. So another great thing that the industry has done, and the whole green building and energy movement has really brought Energy Star rated appliances to the forefront. So almost every single brand has Energy Star rated appliances now. And if you are not selecting an Energy Star appliance, then you are going to be using more energy. So if you're doing net zero, you need to be doing Energy Star rated appliances. Your plug loads. This is also a critical factor in your electric load, and this will all go into your energy simulation models as you're doing design. But the ability to shut down plug loads. So I think a lot of us have heard about vampire energy, and that's energy that's still being drawn when an item or a fixture appliance is not being used. So there's ways that you can shut down rooms with switches. There's ways that you can use power strips. Cheap, innovative power strips. ComEd has programs now for $12 power strips, and they're tied to phones or apps or light switches where you can shut down the majority of your appliances. A power strip, for example, might have two openings for items that you do not want to power down, and you can plug in 4 things that can be powered down on a daily basis. So you think about an office building, most offices are drawing energy from their closed down computer screens that sit at their desk all night. These power strips are able to shut those down, saving energy. So other sort of innovative ways are, elevators and conveyors. How can they save energy? The building that our office is in Chicago, for example, certain elevators only go to certain offices, so therefore they're not going up and down all the time. It'll make you wait for other occupants as it senses cards being scanned, so that it's not doing unnecessary trips. So all ways you can reduce your electric load on that goal to get into net zero. So the next item to talk about is passive elements. So how is your building oriented on your site? Can you take advantage of any passive heating and cooling or natural ventilation or thermal mass? So a couple diagrams here. One is on the left is just a simple solar model, which orients a building on the site, and you can see the solar path throughout the year. So you can begin to see how much sun is getting in those windows, and you can start to consider how much shading should be done on those windows then. So if we look to the right, it's showing you some roof overhangs. So the summer sun is much higher than the winter sun, and we definitely want to avoid that summer sun hitting or getting into our building if possible. You can use window shades, interior, exterior, and roof overhangs, or any type of exterior overhang awning is very effective in reducing the solar heat gain, and therefore reducing the amount of energy it's going to take to cool down that building in the summer. There are certain projects that like to allow that winter sun to penetrate the glazing, so it can heat up the inside of a building for free. Homes are good examples, or multifamily. If you're not at home during the day and you're allowing your building to heat up for free during the day, and you get back and it's stored some of that energy inside your building, it's a really nice way to save some energy there. It's much harder, obviously, in an office building. You don't usually want that sun penetrating too deep into the building and heating up that space, or sort of affecting the work environment. But certainly things that need to be considered as far as passive elements go, and obviously the natural ventilation is a factor in this as well. So moving on to the last step in getting to net zero is renewable energy. So reiterating, the whole first point here is you need to reduce energy consumption first. You're going to do these models. You're going to look at the building before we get constructed, and you're going to be able to get to a point that determines, is net zero energy actually feasible on this site? Do I have enough roof space? Do I have enough site space? And have we reduced the energy load initially? And as I mentioned at the very beginning, if you can't get to net zero energy right away, then at least you can drive down the energy consumption of your building first, and then make it solar ready. So this is something that we're doing on every one of our projects too. And solar ready, to me, and I think to anyone else in the industry, is simply running a conduit to your building, to the roof of your building, so that you can allow solar to be installed, and those wires can be fed down to the electrical panel. So we put, based on the size of the roof, and at that point we usually understand what is the size of the array, and we can size the conduits, the amount of conduits to the roof. Usually it's just 2 or 3, 3/4 inch, 1 inch, or 1 inch lines to the rooftop from the electrical room. We don't even tie it into the panel. It's literally an empty stub that'll be labeled future solar, and it's ran through the roof, it penetrates the roof, and it's got a boot on the roof so that it's flashed and watertight. That's solar ready. If you've got a flat roof, you can orient the panels in any direction. If you've got a pitched roof, the ideal, the optimal orientation is south, but with an east-west roof, you're only losing, and maybe Tim can help me here, but I'd say you're losing about 10 to 20% of your potential energy with an east-west over a south orientation. So it's still very viable. And then the third option, obviously, is the renewable. So we're either doing it on site or on the rooftop or on the ground mounted system. The price of solar is coming way down, and there's a lot of different financial options for solar. So just to show you a couple examples of the price of solar and the demand for it. So this is just really looking at the last, since 2010, actually. If you went back out to 30, 40, 50 years, there's dramatic price decreases in solar. And you can certainly see the demand going up because of those price decreases. So I was just sort of re-educating myself on the tariff that came into play by the new administration. So I think that's part of this drop-off here from 2016 to 2017. And I'm actually still not sure of all those details as far as the solar tariff goes. But again, that demand is still expected to rise. Prices are still expected to go down on the solar. Outside of getting to net zero, there's additional benefits to these high-performing buildings or net zero. Improved indoor air quality, improved thermal comfort, improved acoustic, noise control, visual comfort and daylighting, and as a learning environment. So whether it be a school, a home, or an office, you're in a more controlled environment that's healthier and ideal for learning and working. So I think this is one of my last slides here. Ultimately, the process of delivering net zero is design, building, and testing. It's the iterative process. There's a lot of factors in it. I've touched on the technical details. There's an array of options, but those are the main points that I wanted to drive home. Focusing on the envelope, the mechanical, electrical, water heating, and the fact that you do need a good team. You want to be able to utilize energy models or building performance models to inform design. And then you want to be able to construct it and control the environment that it's worked in. If you can do things off-site, modular prefabrication in a controlled environment, there's certainly high degrees of quality in that. And then testing it. So we need to be using checklists throughout construction, and then once the building is complete, doing your commissioning and determining, have we constructed the building as designed. And ultimately, at the end of the day, you need 1 year's worth of energy bills to determine, are you net zero? So based on scientific data, we really need to be peaking our carbon emissions by 2020, which is obviously right around the corner. It's really nice to see that the majority of the planet has committed to doing this, and it really comes down to how local, whether it's your municipality, your state, or your federal government, how much can they help in driving this down? But we all have a say in it. And hopefully this graph and this chart, gets us to net zero fossil fuel energy over, the next 50 years. So make no little plans. They have no magic to stir men's blood. Daniel Burnham's city planner in Chicago, he did a great job in the city, and I'm sure if renewable energy was a possibility in his day, he would be pushing it and all about it. So at the end of the day, we want to be at 100% renewable energy, and driving building efficiency is the first step in that. So I'd like to see if there's any questions or comments or discussions, from Tim or anyone else on the webinar.
Yeah, please type your questions into the chat box, and we'll be happy to answer those for you. Sean, one of the first questions that comes to mind when you're talking to owners about net zero construction is the cost. Can you tell us what is the differential building standard construction, and you can choose the building style, whatever is convenient for you, but what is the delta?
Yeah. So based off of the case studies, that I've been involved in and the historical data, if we just talk about high performance first, so driving energy efficiency down, there's a delta of about 5%. That's the industry average right now. And it might even be a little bit less than that, 3 to 5% now. So I think that's the first time cost. And then we've got to add our renewable energy to the project. You might be able to speak more accurately to cost per square foot or cost per kilowatt for that, but based off of the recent projects that we've either installed over the last 3 or 4 years or budgeting right now, it could be anywhere from $5 to $6 or a kilowatt that installed on a overall per square foot cost. Tim, do you know by chance, of a per square foot?
I don't have a per square foot for solarizing a facility, and obviously every facility is different. Mm-hmm. For large commercial solar, we're in the $2 a watt range, mm-hmm. And you could easily have like a megawatt scale solar array, but back to this basic question, I'm not talking about absolute costs so much as relative costs. Is it 10% more, do you think, to build a net zero facility compared to just a code, standard code 2018 in Illinois?
I would say that could be used as a rule of thumb. As sort of general speaking, I think that would be fairly accurate to say that net zero energy is going to be in the realm of 10% more. And certainly, I should obviously mention everything that you do as far as energy efficiency and renewable energy has a payback period. So what we're seeing on return on investments on net zero high performance is usually, anywhere between 7 and 10 years, depending on some of the, the energy factors, your actual cost of energy being the most important there. But yeah, all of these investments as a facility owner, a school, home, office, whatever it may be, if you're willing to leverage your money for 7 to 10 years or find financiers who are, there's no doubt that it makes economical sense to do this.
Well, that dovetails nicely with one of the questions we have. Stephen asks, what is the tipping point for involvement, referring to solar? And is it ROI, or is there some other aspect to green building that drives and customer engagement? And, the payback period for solar, just strictly speaking now in Illinois, is 3 to 5 years. So we have very generous incentives in the form of solar renewable energy credits. That's a cash incentive to system owners. That's 25 to 50% of a project's value coming back to the owner in the first 5 years. So I think your point is well taken, Sean, that we have to think about the long-term return on investment. While we may be spending more to, first of all, build a super efficient building and then putting renewable energy on it to get to net zero, but we're going to see a return on that investment in reduced energy costs, in improved health and performance of the building occupants, which is something that is often neglected and really not promoted so much in the green building arena. But that's kind of the next frontier, is to really document how does this impact occupants and create a more sustainable and livable built environment.
Right. And as far as the tipping point then, from Stephen's question, what is the tipping point for involvement? And if I'm understanding the question correct, is it strictly money or ROI, or is there business marketing that play a role in it? I think, it's a great question. From my experience, what I've seen, it's really it's someone on the design team, whether it's an owner or a champion on the design team that's involved in the design. So it could be the general contractor or a consultant. But it's someone driving the point about net zero or the ability to get there. It seems to be, it's an unknown or misnomer for a lot of people, not really understanding what it takes. and it takes a little bit more effort, and that's really it. All the technology is there, the economic or financial instruments are there, the professionals and the talent are there. So it just takes someone sort of driving the point home, reminding the team, this is possible. Obviously, in the best case scenario, it's an owner that's driving it, and they're looking at 7 to 10 years or 3 to 5 year paybacks, and they're like, that's nothing. That's nothing in the grand scheme of the building that they're going to have. So then it takes really that goal and that ambition from the beginning. I will say, to Stephen's question, the ROI obviously is critical to a lot of owners, and that is usually the first thing that they're just not, budgets are tight already, and they need to come up with another X amount of dollars to make this work. That's the unfortunate side. That's why I want to see more policy that's incentivizing and encouraging these types of projects, because it's so feasible when all the players are there, and you've got financial instruments that can help offset some of these initial costs.
Yeah, I want to highlight that policy is critical, and as I mentioned, we do have really good legislation in Illinois now called FEJA, the Future Energy Jobs Act, and that's funding not only renewable energy systems, but also energy efficiency. You mentioned the program, is it seventh generation, or what is the name of that? The seventh wave. Yes. And so if you're, so just know that if you're in the process of designing a new building or a major retrofit, then you should definitely connect with ComEd and Ameren, depending on where you are in the state, and find out about these free consulting opportunities that will help you design a more energy efficient and sustainable building, and then also funding the actual, construction. There are incentives to help fund energy efficiency in the building itself.
Yep.
Well, thanks, Sean. We don't have any other questions, so we'll hang out here for just a couple of minutes. If you have a question, please type that into the chat box. I wanted to just circle back, Sean, to your background. How did you find out about net zero and get interested in, some of these more ambitious forms of construction like passive house?
Well, yeah, it goes back about 10 years. I grew up in the construction industry, so I was always interested in the industry itself. But I also saw, I think at an early age, some of the inefficiencies and waste, whether that's in the construction process or the energy waste. And there was an inspirational book I read. It was probably in 2007, 2006, called Natural Capitalism. It made some really strong associations between buildings, energy consumption, and the environment. And I think those three things, I guess, would be, some of my biggest passions. So it was just, it was the inspiration of actually just reading something that made sense to me. It connected the dots, and I felt like being in an industry that has the biggest impact on energy and the environment, then knowing that information, I felt like I have a responsibility now to influence the future of our industry, whether it's a small impact or hopefully a larger impact. I think it's critical that, those of us in this industry, need to contribute to reducing energy. So yeah, that's how I got involved, Tim.
I feel the same way. Once I learned about LEED and Passive House, I just, I wanted to be part of that, and to create a legacy for future generations. We are, as a society now, going through the transition to a cleaner, greener future. It's not necessarily a painless transition, but it's a totally possible transition with the technologies that we have today. And of course, here on the webinar, we talk about solar energy on a monthly basis. And so check us out on YouTube, SolarWorks for Illinois. I'm your host, Tim Montague. Thank you so much for joining us today, Sean. I really appreciate the opportunity for you to share with our listeners about net zero construction. And I will be posting the recording here, like always, on our YouTube channel. So again, thank you so much, Sean.
My pleasure, Tim. Thank you for the opportunity. I hope the audience got some good information from me. And if you have any questions, you can always email me at smoran, M-O-R-A-N, at Skender, skender.com. Thank you, Tim.
Can you put up the last slide, Sean, where we have our contact info?
I'm sorry about that. Yep.
We'll get that on the recording. And then I just wanted to make one announcement that our next webinar is October 30th. And the topic there is maximizing your solar investment by adding battery energy storage. And the speaker is Travis Simpkins, PhD, founder of MuGrid out of Colorado. So we're really looking forward to having Travis on the show. Again, I'm Tim Montague. This is SolarWorks for Illinois. Thank you all for attending and have a great day.